Next, let's work through some volume and scaling examples. So last time we had this shape here consisting of a triangle, a rectangle, and a semicircle, and we figured out its area to be 766.08 square centimeters. Now let's imagine taking that shape and extending it in a third dimension by 10 centimeters to create a solid. And to calculate the volume of that solid, it is the area of that shape that we worked with last time times the other dimension, the new dimension, 10 centimeters. And so that comes to 7,660.8 cubic centimeters. And that's how many volume calculations can be done, by finding the area of one side of the solid, and then if the solid consists of just extending that area in a third dimension, just multiply that area by that third dimension to get the volume. Now let's suppose we think about scaling. So scaling is where we take the measurements and we increase them by a factor or decrease them by a factor. So for example, let's suppose we took this 20 along the top of this shape and multiplied it by 2 to become 40. And then similarly we take the 24, the diameter of the semicircle, and we multiply that by 2 as well. And then this distance here, which if we think of this as a triangle, represents the height of that triangle. I suppose that gets multiplied by 2 as well. And then just thinking about the area of this shape first, what happens to the area compared with the area that we calculated last time of 766.08 square centimeters? Well, let's try and do that area calculation without going through all the steps that we went through last time, but instead just applying scale factors. So this 24 is multiplied by 2. That's over here. This 5 is also multiplied by 2. This 20 is multiplied by 2, as is the 24. And then for the semicircle part, the 12 here, which was the radius, is multiplied by 2. But notice the radius gets squared, so that scale factor is squared as well. And so each piece of the area, the triangle, the rectangle, and the semicircle, is increased by a factor of 2 squared, because we've got times 2 times 2 here, times 2 times 2 here, and times 2 squared here. So each piece is getting multiplied by 2 twice, or multiplied by 2 squared. And so when it comes to figuring out the area of the new shape, if we increase each of the dimensions by 2, the area is going to increase by a factor of 2 squared. So it'll get multiplied by 4. And 766.08 times 4 comes to 3,064.32 square centimeters. Thinking about the volume now, let's suppose that the other dimension on the volume, the 10, also gets multiplied by 2. Then the volume is going to be multiplied by 2 cubed. And 7,660.8 times 2 cubed, or 8, comes to 61,286.4 cubic centimeters.